So starting today, we will be moving to machine learning. Okay. So very important. Maybe you guys can take notes. You can understand, ask questions. Hmm? So what is machine learning? Can someone just tell? So
It is
machine
a
learning,
subset of artificial intelligence
yes.
where models will be learning from humans, from large data.
Yeah. So basically, machine learning is part of AI. Okay. Uh, how can I draw? Drawing. So let me draw a canvas. Then we'll define each and every term. So suppose this is your canvas. Okay. Maybe I need to draw big. So I'm drawing the circle and trying to make you understand what happens. So first we'll see how it works. Okay. Uh, then this is not highlighted. Okay? So this entire canvas, big part. Okay? Big part is AI. The entire circle is AI. Okay. Then the portion of this is machine learning. Then this third one is deep learning, DL. And after that also we have certain things okay, which are very small. So you can say this portion, right? This portion is Gen AI. And then the small portion here is agentic AI. Okay? This small portion is agentic AI. Okay? So if you look at this circle, what is the AI? Right? So let us come to AI. So basically AI is everything. This complete thing is AI. Okay? Then we have machine learning. Then we have deep learning. Then we have Gen AI, generative AI, and we have agentic AI. So one or two classes will learn all these terminologies, okay, so that it will be easier to uh, learn the practicals. Okay. So now what is AI? So, so AI stands for artificial intelligence. Right? So basically you can define it as it is a branch of computer science. AI is a branch of computer science where we try to provide, right, intelligence, human intelligence to the machines. It is branch of computer science where a programmer or developer, right? Developer tries to provide human intelligence to the machines. Okay? Tries to provide human intelligence to the machines. Okay, suppose in traditional computer science, what happens, right? So far clear, right? Artificial intelligence kya hai? What is this? It is a branch of computer science where a developer, programmer, or data scientist tries to provide human intelligence to the machines. Means machines will try to think like human. So machine doesn't have brain, right? Today, if you look at your computer, right? If you're purchasing a new computer, right, it doesn't have any brain. It has only CPU. It has like all the hardware software installed. Right? So Notepad is there, MS Word is there. Right? But if you just open a Notepad, it won't do any work. Right? You have to write something. So if you are writing something, right, next day you will get the same output. So machine is not learning anything, right? Because we have not given human intelligence to it. Right? So here must in AI, what will happen? Machine will think like human. Right? So this is basic terminology I'm talking about. How it will learn? It will learn using machine learning. Okay. So now I'm coming to ML. ML is machine learning. Okay. So basically, machine learning, you can think what is machine learning, how it works. Right? So the basic example, the best real-time example is suppose a child has taken birth and he is in hospital, right? Or maybe he is in at home. So suppose a small child is there. Right? I don't know how to draw. So this child has taken birth. So at the time of birth, he he doesn't know any language. His brain is completely empty. What he knows, he only knows how to laugh and cry. How to laugh, how to cry. Right? Even he only knows like how to eat, how to drink milk. Right? These things the child knows. Right? Now, right, surrounding to this child, there is a guy. There are people. Means his father is there. Right? His mother is there. His mother's friends will be there. Right? And suppose this father speaks Tamil. Right? Mother speaks English, something like that. Right? And his friend speaks Hindi. Right? Now, these guys are around child and they are talking normally every day. So what happens is this child, right, tries, keeps on getting information from father. Means he's listening Tamil also, he's listening English also, right? He's he's listening Hindi as well, right? And if suppose someone is speaking French or something, so he'll get information from everywhere. So this child is bombarded with data now. This information is nothing but data for him. So he starts learning, right? Now he is listening first. And as he grows, right, as the child grows, he keeps learning small words, right? Like first he will gather everything, right? So maybe Tamil, English, Hindi, everything is going in his brain, right? Then when child comes like becomes 6 months or 8 months old, right? Then what happens is he is first telling word, first word he will be telling either appa or amma, right? Appa or amma, right? And we became very happy that my child has taken my name, right? So he's not taken your name. Maybe every day you are telling that appa here, amma here, right? So those things he understood, right? And whenever he sees you, right? Whenever he sees you, so he is telling appa amma to everyone now, right? Um, appa irka, amma irka, you're telling right? So he is telling appa amma. So what happened, right? Maybe in 6 or 8 months, right? Since he has a brain, he has acquired knowledge from you, right? And he started speaking very small words now, right? So this is the story until 6 to 8 months. But when child grows up, maybe once he becomes 1 years old, so he'll talk something else also, right? Ma what? Tani when ma or something, right? So he will ask about water, right? I need water or something, he will tell. Then he started right, speaking little small sentences. So what happened? Right? He learned. Right? Even though he did not read it. Right? He did not go to school or he did not go to college. What happened is he was surrounded by the information around him. So all these informations came to him, right? And now he started speaking. When the child grows, once he becomes like 2 years old, 3 years old, so he starts talking fluently. Right? So machines also learns in a similar way. Okay? So machines do not have brain. Okay? So machine learning, what is machine learning? As Saundarya explained, right? Saundarya, what did you say?
A model which learns from lot of data.
Yeah. So basically, machine learning is, so your computer is there. Right? You will just develop a small model. Model is nothing but a set of instructions, or it can be a data also. Right? Suppose, okay, let me first define. So far, this example is clear, right, guys? That he is learning from, there is no algorithm, there is no programming done here. What he is doing is he is only acquiring knowledge based on data. For him, data is the languages here, maybe words, sentences. So machine learning is, right, it is a way to, so it is a branch of artificial intelligence. It is a branch of AI. Right? Where a machine or model, right? Model learns from data. Now, this data can be anything. This data can be anything. This data can be, suppose there is a table, right? This data can be tabular data. This means label data. This data can be anything. So maybe label data. I'll give you an example, right? So this data can be unlabeled also. Unlabeled. So first understand what is machine learning. It is a branch of artificial intelligence where a machine or model learns from data. Okay, this is very important, right? So far in NumPy and Panda, what did we do? We created data. Right? So I'll give you a small example of a label data. Suppose I have developed a small model. Okay? So one model is there. We'll come to model what it is. Right? Model means few lines of instructions. Few lines of instruction you have given, right? Maybe it can be a mathematical rule, mathematical formula or rule. So you have given mathematical formula to model. Yeah. So one example, very good example. Okay. So suppose there is a cat here, there is a dog here. Okay. Now, initially, right, if you are creating a model for machine to identify that this is a dog, this is a cat, we have to tell him, tell tell it that this is a cat and this is a dog. So for a machine, right, we have to show machine multiple images of cat and dog, right? You just give him many images, right? Okay. So give image one and say that this is cat. Give image two, say this is dog. Then image three, show him again another image of cat and dog. So likewise, maybe lakhs of images, right? Lakhs of images will be given to machine, right? And it will be labeled. So you will be writing that this is cat and this is dog. Okay? So machine will remember. Machine is learning like, okay, if something comes this way and it has a tail, right? And it has something, right? So it is a cat. Right? But dog also looks the same way. But you are giving machine the actual images, right? And not one or two images. So machine has to be trained on maybe lakhs of data, right? Very huge images you are giving to machine. Right? So machine slowly starts learning, okay, if something is coming, which has a tail, which has the color is like this, right? So this is a cat. And similarly, it also knows what is dog. Right? Yeah. Now, suppose you have trained machine with 1 lakh data, right? On 1 lakh images or 2 lakhs images, right? 2 lakh images I have given and machine is ready. Next time, you just give him a image of dog. Okay. So again, I'm giving the image of dog. And this time see here the images had a name. Label means the image will have a name. So machine is understanding, remembering that cat looks like this, dog looks like this, right? And now I'm giving another image which is not labeled. So this is an image of cat. We know this is a cat, but give the image of this one, then machine will tell this is a cat. Okay. So what machine did? Based on these images, right? And based on the model you created, a small set of instructions, right? It learned over the period of time, okay, on huge data, and it has got the intelligence to guess or to predict, right? So now machine is able to predict. So now until here it learned, right? Tomorrow, right? If you're giving an image of a Doberman or German Shepherd, right? Dog, and asking machine to predict what is this image. So it will be able to tell you this is a dog. Maybe it will not say this is a German Shepherd, this is a some dog, I don't know, Familian or something, but definitely it will predict dog, right? So what did we do? Right? In our machine, we deployed a small model. We trained it on a multiple set of data. Okay, we trained it with uh, and machine became intelligent, right? Based on our model, and now it is able to predict on a new image. So this is a new image I have given, right? This is new image, and now machine is able to predict, right? Is it clear?
Yes, Kedar.
Yes, bro. Yeah.
So machine learns in this way only. If you will not give a good data set, or if you will not train it on large amount of data, machine won't learn anything. Okay. So it is very important that we train it on right data set, okay? And machine will learn itself. So for that, what is the requirement? Right? Not much. Right? What did we do? Right? We just wrote one model. And inside this model, you gave some instructions. Second thing, what we did, right? We gave the machine labeled data. Labeled data means the images were having name, right? The image was having name. So this is cat, something like that, right? And this was having dog, something like that, right? Now, third thing, when you are asking machine, right? You are giving a input. This is a some other dog. Maybe those dogs machine also saw. So here it got trained on a large number of data set, right? Large number of training data you have given, right? Training data. Now you are giving a unknown dog image, okay, which is not labeled. So it is able to tell that this is a dog. Now the problem comes, right? So suppose I'm giving a uh, lion image. Suppose lion is like this, big mouth and very big, right? And I have not written anything. then what machine should do? Right? It should say that I don't know.
That is also called as a unlabeled data.
Yeah, so I have given the image of lion and we have not written here cat, dog or lion. So machine has already learned that how cat looks, how dog looks, right? And it has everything in its memory, right? So when it sees lion, it will say that I don't know. I do not have this information, right? If you are giving a image of bike, you have not written bike here. So it will say that I don't have this information, so I don't know, right? So this was until like 2023, right? That on unknown images, machine was not able to predict, right? But okay, so these things will see in like Gen AI and other things, right? Deep learning. In deep learning and all, these answers will be coming. That this is lion, this is this, right? So I'm just keeping it aside. We'll discuss in deep learning. But let us learn about machine learning. Okay? So what is happening here, right? So okay, so let us try to categorize things. Now I have this data set. I have this data set. Okay. Now I'm going to actual data. Okay. So this is suppose number of hours a student studies. Number of hours, study hours. And this is marks in percentage. Right? Marks in percent. Okay. So suppose if someone studies like 3 hours per day, so he is getting around 60% marks. 4 hours, then might be 65%. 5 hours, then his marks will increase to 70%. 8 hours, then 80%, something like that. So on, like there is a very big data, right? And all are not linear. Right now I'm giving a small set, right? So if someone studies like 12, 13 hours, so he will become topper, like 95% or something. So the machine learning models and all, which we will design, right, in upcoming days, will take this kind of data. Okay? And there is a model called linear regression. This model is already developed. Okay? So we'll use it, and we will also learn how to create linear regression model from scratch. But right now, I have not written anything. I have this data set, right? So first my responsibility will be, right, clean this data. So right now this data is clean, data set is clean, but there are billions of data set, right? So you will be cleaning it, and we cleaning part we already learned in EDA, right? Exploratory data analysis that day. Like nulls are not there, marks missing, so all those things will be done. Okay. Now from here, how machine is thinking, right? Maybe machine will think like human also. So I have a pattern, right? So if someone studies 3 hours, right, it is getting 60%. Someone studies 4 hours, getting 65%. Right? So what machine tries to do is machine tries to create a pattern in this way. Right? It will draw a line. Right? Suppose someone studies 3 hours, then he is getting 60%. This is 60. So it will say, okay, my 3 and 60 comes here. 4 hours, then 65%. So it will say that, okay, for 4 hours, 65%, 65 is here. 5 hours, then 70. So 70 will be coming somewhere here. So it will try to draw a line of base fit. So this line goes like this. This is called best fit line. Because right now we have only few points, but there are possibilities that these points are scattered here. Someone will come here. Few points will come here. He will go there. He will be, if outliers are there, it will go there, right? So it will ignore these the points which are far away. Right? We learn the techniques how to draw best fit line all, but try to think in this way, right? That I gave machine only this. Right? So in order to train machine, what will you do? You will give a line like this. Y is equal to mx plus c. This is equation of a straight line. So we are only writing this, okay, and giving data set. Right? So let us not go to the line now. I'm just telling you. Now, suppose I have trained my model. This is my model. Okay. So this model, what it does, it generates a straight line. In linear regression, this is the mathematical formula they use. Okay. Now, so it's okay. We developed machine learning model, and it learned from this data set. Right? What will happen if I'm giving, right? Suppose a student number of hours I'm giving. Right? If I'm giving number of hours equal to suppose 9. Right? Now machine has to see. How do you know that machine learned? Because we train with this label data, right? Number of hours and marks. So this is the input for machine. 3 hours is input and 60 is output. So as we are learning as a human, that if a student uh, studies more hours, he will get more marks. Right? Similar way, machine also predicts using this model. Only this much is model. Okay? Using this formula, machine is learning. If number of hours is 9, right? Then what will be my output? Right? What will be the marks? So yeah, this is on prediction that you are giving machine on some data. This data is not available here. So definitely machine will give the answer between 80 and 95. So suppose it is giving 85%. It means the model is working now. So this is the prediction of model. Prediction of model. Clear here? For any doubt? The basics are very much needed. Now, based on, are you guys with me?
Yes.
Okay.
Yes, Kedar.
Yeah,
All right. So, any doubt here? No, right?
Okay, that's
Now take another example. So that was what student marks analysis. In real estate, there is a famous house price prediction. So let us draw a data set. Right? House price prediction data set will be looking like this. I'll first draw a smaller one. So the label data may be square feet and then price. So maybe like if house size is 600 square feet, it will be coming in 30 lakhs. It is in lakh. 700, then 40 lakhs. 800, then 40 lakhs. 45 lakhs, something like that. So here also you will use the linear regression model. Machine will see how you are learning, right? If a square feet size is changing, right? It increases, that price will increase. If it decreases, right? Suppose someone is selling 300 square feet house, somewhere like 15 lakhs will be the price. Okay. So your data set will be like this, and you have to analyze the data set and then select a model. So here also we will select linear regression. Now coming to the main point, this is your feature. This is your input. Input variable is how much. In this example, input you can give like x value, x equal to square feet, and output is y variable, which is price. So this is known as dependent variable. See, house price is dependent on area. Right? So 40 lakh is for 700. So basically what is happening, this y is dependent on x, or you can say y is a function of x. Or when you give linear regression model, then you say y equal to mx plus c, where m is the slope and c is the intercept. Those things we'll do tomorrow. Don't worry on this. Then another example, spam detection, spam email detection.
Bro, I'm just taking notes. Can I just you go up?
Yeah. So what I'm saying is, Lima, in this case, right? This price is changing, no? So price is dependent on square feet. Correct? So when you are drawing the model, you will say that, okay, price is a function of square feet, means area. So this is price will be coming on y-axis. Here price will come, and this side area will come, square feet.
Yeah.
So if area increases, price goes up. For 600, the price is 30 lakhs. So the point will come here. For 700, 40 lakh. So your point will come here. Similarly for 800, the point will be somewhere here. So if you draw straight line, it will go like this. So if you're asking a model, right? Suppose I have like 1,000 square feet, right? Just telling that what will be the price of a house whose area is 1,000. So model will draw a point here, 1,000, and it will just try to, it doesn't know, right? How much will be the price. How it does, right? From here it will draw a straight line, and whenever it cuts into how it was internal, whenever it cuts to this best fit line, right? That will be your price. So it will calculate from here until here to here is 1,000 square feet, right? So how much is this? Because from here to here one line will come. So suppose this is like 60 lakhs, right? So it will say that okay, for 1,000 square feet, right? I have drawn a straight line, and from here it has drawn a straight line. The value is coming 60. So it will be able to tell you that for 1,000 square feet, the price will be around 60 lakh. Okay? It can be 59.5, 50, 58 as well, right? So that depends on how good is your model. So basically, this price is dependent on square feet, right? Price is dependent on area of the house. That's why we say the price. It is very important that you understand this concept. Price is dependent variable, right? Dependent variable is a variable which can be automatically calculated based on independent variable. The square feet is anything, right? We can do anything. I can take here like 100 square feet also. So this 100 is not dependent. You can take any arbitrary value here. So your area or square feet is independent. It does not depend on anything. So basically, how will be the equation? Price is equal to square feet, right? Function of square feet. So it will say, when it drew this straight line, equation of straight line is y equal to mx plus c. What is y? Y is price. So you have to provide like this. Price equal to m into square feet plus c. This c is intercept and this is slope. We'll see later. Clear?
Yes, bro.
Okay. If someone has any doubt, please tell me, guys.
Okay, that's just you're teaching only the formula, right? We didn't apply it, correct?
No. It's a basic class. Right?
That's okay.
So I'm just telling what is AI, what is
Y
machine
equal to
learning.
mx plus c. We have to remember m is slope and c is intercept. That's it,
Yeah.
right?
Yeah. So right now I'm teaching formula.
Yeah.
Model and everything creation will be happening tomorrow. Okay.
Sure. Okay. Thank you. Okay.
So I was going for a spam email detection. These things will do. These projects will do. Okay, one by one. So spam detection email, how it works. Spam email detection. So let me open my Gmail. I'll show you. So see here, so email is coming. Email comes. Now the email is getting categorized on primary. Right? Primary means like all the valid emails, right? All the verified users. Right? There is no spam, things like that. So the email is getting categorized into primary, right? Based on certain criteria. Right? What Gmail does or what Google does, it is running a machine learning model. Okay, on where that machine learning model will be hosted, where this mail.google.com is hosted. Right? So there it is running a machine learning model, right? And that model is for every user. It is not for us only. It is not for me. It is not for Maithili. It is not for uh, Nishil, right? That machine learning model is a generic model. Okay. Now, when Google might have created it, right? Now it has, see, it is beautifully characterizing it into like primary email, right? Promotion email. If somebody is telling that new feature is launched, right? So it is going to promotion here. Right? All promotional emails are going to promotion folder, right? All social emails, right? Maybe from LinkedIn, WhatsApp, not WhatsApp, what is Facebook, Instagram, those emails are coming to this one, right? And there is update also. So if you are not using some email very frequently, and that is important, it is putting in the update folder, right? Because these are not spam. But there is a folder called spam here. See here, spam emails are those emails which are of no importance to us, okay? And we hardly open it anytime. So like Google spam email detection model identify user behavior. If you have not opened anytime anything, right? So see here, I don't know from where this email is coming. So portfolio from somewhere, I might have opened it like 10 years back, but still emails are coming from here. Now it identify that this email is of no use for me because in last 2 3 years I hardly clicked any email. I hardly uh, check them. Right? I'm hardly logging into this money control website. So user behavior is being detected here. Right? And based on that, it is characterizing emails. Right? So how it works, I don't know the entire nitty-gritty around it, but suppose whenever we will be designing our spam emails, so what we will do, spam email tricks. So we will be designing a small algorithm. Okay? Means we have to design a model. If linear regression is fine, then we'll do linear regression. Otherwise, we will go for some other model. Okay? So in order to showcase, right, I have to give a email to this model. Right? We have to show email to this model. Okay, that this email is not spam. We'll give a email and we'll tell, right, this email is not spam. Like in the cat and dog example, we are showing a image and telling that cat. So we will be showing email contents, everything to model, and we'll tell that this is not spam. Okay? And we have to also showcase email, right, which is spam. Okay? And this we have to do multiple times, maybe lakhs, 1 lakh emails for not spam, 1 lakh emails for spam. Okay? Something we have to do. Okay? Now this model will learn, okay, if some email is coming from moneycontrol.com or like some website which is not useful for you, then it will put that into the spam folder. Okay. And frequently emails, like what is frequently emails? Right? Maybe any notification coming from HDFC Bank or some friends is sending you, right? So those emails will be categorized into your primary. So here also we are training model on a large number of data set. Right? So here, in order to design spam email detection, what are we doing? We are giving large amount of emails, okay, of two categories. One is spam email and second one is not spam email. Right? Now you train this model, right? Training is done, means your model learned. Now, if I am giving a email from like moneycontrol.com or something, right? Control.com and email contents are there. Now it has the ability to categorize in spam folder. So this will go in spam, right? And suppose I'm sending a mail to Maithili, right? Then in Maithili's folder, my email will be going as inbox. Okay? So this is a not spam email. It will go to your inbox or primary. Right? So here also we are in email detection. We are providing label data. Okay? Anyone has any doubt? Team?
No, Kedaji, clear.
Okay. So many things are there. We will learn slowly. Okay. Now I have to tell something about types of machine learning models. So one is types of model, or you can say category. This is not model. You can say that like one is supervised learning. So in supervised learning, what happens? We train machine based on label data. We already saw. Here the machine is trained based on label data. Right? And the best example was linear regression. Right? Second one is unsupervised learning. So here in supervised learning, data was labeled, but data was having a name. There is a possibility, right? data will not have name. Like so in supervised learning, data will not have. So data will be unlabeled. Suppose today when we go and create something, right? An account or something, right? It asks for like your face recognition. Your fingerprint authentication. So all these heavy lifting tasks, right? Here the data will not be labeled. Okay. This will be working on unlabeled data. So for these different models are there, we'll see them. We are just seeing today supervised learning, unsupervised learning, and third thing is third party, like based on like what we call mostly like self-driving cars and all, right? Uh, so we provide them if, if it is driving well, we will give them award. If it is not working properly, so we will be giving punishment to that. So that is known as, let me see the name. Okay. It's not linear overfitting, unfitting. The third one is reinforcement learning. And believe me, these three are very important from interview point of view. So suppose someone is creating, maybe Tesla has given a self-driving car. So what happens in reinforcement learning? It is kind of trial and error. Okay. It is called as trial and error model. Okay. This is very good for all the like human kind of work. Right? Trial and error. So basically, you created a model. Right? You created a model, and you have given a set of instructions, right? And what it does is, right? Suppose self-driving car is there. So now this model is there. It is driving a car. Suppose it is driving BMW car or whatever in US, very famous. Or Tesla has created its own car. So maybe if self-driving car model is deployed on BMW, so it will be deployed somewhere inside the hardware. And on the driver seat, there won't be anyone. This driver seat is empty. So car is moving by itself. When a zebra crossing comes, in the main road, you must have seen the roads are there. Right? In US and India, there will be zebra crossing and it will be in white color. white or yellow, means this is meant for pedestrian, right? People to walk. This is meant for people to walk. Suppose your car is here, right? Your car is here and it shows zebra crossing and it does not see people as well. Then what it does, right? It has to stop here. Or it has to slow down, stop here. Right? If it is stopping, then you will assign some reward to it. If your car is stopping at zebra crossing, you will be rewarding. So give some reward. Maybe reward for 0.1, some precision will be there. Now same car is moving now, and there is a traffic signal. Here signal is there. If in the signal, right, it has to work according to the color of the signal. Right? Suppose yellow comes. First let us take red. In red color, it has to stop. Then when the signal become yellow, it has to get ready or start it if the engine was stopped. And when the signal is green, then it has to move. So if this does everything here, you will again give some reward to it. Right? So again 0.1, this reward will be like 0.2, something like that. So you will keep rewarding it. There will be multiple use cases around it. Right? Now a traffic congestion is happening. It is the car is moving. There are so many vehicles, right? And it has to identify the vehicle which is ahead, which is behind, right? And it suppose it is going on lane 1, it has to move in lane 1 also, okay, like a real driver does. Suppose one car is here and it is damaged, right? So suppose this car is damaged. Someone sells car, not this is our self-driving car. This is our self-driving car. Now self-driving car got stuck and before car got damaged. Okay? Now it cannot move. Right? So what will happen is it should not keep waiting here. Right? It should either go to the lane 2 or lane 1. Suppose lane 0 is also here, so it might go this side as well. Right? If it is not doing it, if it is becoming like idle or standing here itself, then you will punish it. Right? So suppose if so reward will be smaller, punishment will be big. Right? So you are giving like 0.25 of punishment. Right? So this way, using trial and error method, right? Giving rewards and punishment, whatever model we create, that is known as reinforcement learning. Right? We are imposing some rules to this. Right? And if it is not behaving according to that, you will punish it. And if it is behaving according to that, you will reward it. So when will you release this to the production or for this? When you have tested it for like multiple years. It is very real-time thing, right? It's a real-time application car. So you will be releasing this car or this model only your confidence score is like, I'll say that 99.9%. Okay. And how it is calculated? First, your this matrix. Okay. So suppose you're calculating the output. Okay. So initially, it will start with 0. Your model will start with 0. Okay. Then if does some good work, maybe it is stopping in traffic signal and all, okay, you will add 0.1 here. Okay. Then if it is following red signal also, you will give like 0.01 something. Okay. This way there will be lakhs of parameter. There will be millions of parameter on which it will be tested. Okay. So if it is giving pass, or suppose if your car is looking at one school bus and is stopping, right? So you will reward it at 0.11, something like that. Right? Then this will keep on continuing. Somewhere it will be minus also. Right? As I said, that reward will be more, reward will be less. Right? Reward points will be less, and punishment point will be more, because we don't want our model to do a small mistake. Right? See, in traffic signal and all, if it is deviating something, right, that is not life threatening. Right? But suppose a train is crossing here, right, and this car moves, right? Maybe you can do -5 points. Okay? So likewise, when your output, right, reaches the sum of everything, like reward and punishment, reaches around 99.99, right? Maybe 100% precision, then only your model will behave properly, and you will be releasing this model to production, right? Or in the live, you will be releasing this to the market. But this is for India, and this is for US. Right? The same model will not work in India, right? Because in India no one follows traffic rule. People will go here and there, then, right, people will be honking, things like that. So there is no traffic adherence even in Chennai is not there. Small towns will be very difficult. Right? So this same kind of model will not work in India. Right? That's the reason Tesla has not released self-driving car in India. Okay? So if one model works in one country, one region, in one place, in one use case, it might not be working in other country. Okay? So far, supervised learning, unsupervised learning, and reinforcement learning is clear. Let us revise again. Supervised learning. Right? Can someone tell what will be the type of data?
So kind of
Labeled
linear,
data.
yeah, label data.
Yeah. So this is very important. We understand that data should be labeled. Labeled data means data will have name. Every data will have name. Okay? Supervised learning. Unsupervised learning.
Unlabeled data. Example,
Yeah.
face recognition.
So, unlabeled data. We'll also revise the algorithm. Right? Here, what was the use case we studied?
We saw spam mail and this land rate, square feet versus the price. regression,
Yeah,
linear
linear regression.
regression.
Tell one guys. So one is like house price prediction.
Another one, study time versus marks. Email detection,
Spam email
Spam
detection.
email detection. Third one also we saw, right? Student marks analysis.
Yes.
There will be many use cases. Right? And the model which we created for this was linear regression. Right? We'll do it tomorrow. Then second thing was
reinforcement learning.
no. Unsupervised learning, no?
Oh yeah, okay, unsupervised.
Here data will be
Unlabeled.
unlabeled. So unlabeled data, there will be multiple examples. Okay? Any data which you are not giving name is unlabeled. Right? Here we saw the example of like face recognition. Right? Then fingerprint authentication. There are many things possible, right? Someone wants to do a payment using eye blink. That for him, it is also unsupervised learning. Our UPI is being created, right? When our UPI was being created, UPI is one of the biggest application in world. Okay? Our like Google Pay, Amazon Pay, these things, right? So UPI is developed by India, right? And everything is machine learning idea, right? So think, no, that you are sleeping, bank is closed, right? You are sending money to A to B. Right? There is a very complex algorithm works here, and your payment happens in 1 second, not 2 seconds also. So inside there are huge machine learning algorithms. Okay? Maybe your payment is suppose you want to send 100 rupees to someone, right? So it goes to your API gateway. From there it goes to bank. Bank is closed, but bank will say that okay, there is some balance. Balance is available, then it will authenticate, authorize, right? And then the payment will be going to B. So this everything is like unsupervised learning. Okay, there can be lakhs of algorithms here. We'll do many as part of our projects. Okay? Now third one was reinforcement learning, right? So this is a real-time application, right? All are real-time only, but this is very critical, right? Reinforcement is done when you are doing critical work, right? So here, how do we do?
Right.
See, there will
Trial
be
and error.
so here the data is real-time objects, okay? Real world objects. What do I mean by real-time objects? So for self-driving car, what was the object? Everything is object for him, like road is object. Then other cars are objects. Signal is object. Then many other things, no? Like petrol bunk is there, right? It has to fill petrol. It will go fill the petrol. Right? Then a school bus, railway station, everything is coming as object for it. That's the reason, since it it is replacing human completely. Right? Reinforcement learning removes the human completely. In a self-driving car, what happens? The car driver will be replaced with a robot, right? Not robot. Robot also won't be there. Some machine learning model will drive it. Okay? It is programmed in such a way. So if you are doing some critical work, you will use reinforcement learning, and here we will do reward. We'll give reward and punishment. If it does something which is I told it to do, then we'll reward it, and punishment will be given if it does not follow the instructions. So here the punishment will be greater than reward. Okay. You are punishing him heavily so that next time it will not do a same mistake, because those mistakes are life threatening. Accidents can happen. People will lose life. Okay. And here the training is done for huge period, right? Very long period. Training is done for huge data set, long period, real-time objects, everything. Recently, India sent some what do you call, some vehicle to Mangalyaan and all. Right? So there were some cameras and all installed. Those cameras will send real-time objects, real-time images from Mangalyaan or Chandrayaan. So here everywhere reinforcement learning is reinforcement learning is applied. Okay. So far it is clear. Now I will be moving to linear regression. Okay. Sudhakar.
Yes, sir.
So Tamil, everyone is clear, guys?
Yes, sir.
Yes, Kedar.
So we have some time. I want to move to linear regression now. Okay. Okay. Before going there, I just want to make sure that how machine learning is different from traditional computer science. So in traditional computer science and in machine learning, can someone tell the difference? So in traditional machine learning, what we do, we provide, so we are writing code, right? And we also give input, right? So maybe we are giving data and instructions, right? Instruction we will write, right? If x is greater than 5, then do this. If x is less than 5, then do this. So we are giving data and instructions and we get output, right? But in machine learning, you are just passing data, right? And you're also giving output. We gave, right, in-house price, or maybe when a student was doing 2 hours, it will score 60%. If he is studying 3 hours, it will be 70%. So we are giving, so this is my data. Input is data, and I'm also giving output. So it will learn pattern, right? So biggest difference is this. In computers and traditional, like maybe binary search or whatever program you write today, which is not part of machine learning. So we give data, right? Like uh, calculate if string is palindrome or not. So you'll be passing like palindrome string, right? You'll passing a string here. String is your data, and you'll be writing the logic. Right? The logic is known as instruction. Right? And based on that, it will say that whether this string is a palindrome or not. Right? So you will get output here. So what happens in this scenario? Here the machine, even though you have set up instructions and all, it will not learn anything. Right? It will not learn over the period of time. So learning rate is 0 here. No learning. But here, based on data, data is your hours study, right? And output is marks. I provided these things to machine, right? And it is able to predict, right? This is an important difference and we should know this. Okay. So what is the difference between AI and ML? Now, so far we have reached here. Think about that big thing, right? We drew, no, that now we drew this circle, right? So this entire thing is AI. This is AI. Entire canvas is AI. And machine learning is the branch of it. Now, this is machine learning. So machine learning is a subset of AI, right, using which we can make a machine as intelligent as human. So far today I have only covered AI. Okay? AI is this canvas, entire thing, and machine learning is a subset. And using machine learning, you will make an AI system intelligent. So you can also say machine learning is a way by which an AI learns. AI can be anything else. Right? AI can be your robot. AI can be uh, your program. Right? I don't know whether you guys know or not. My sister is stays in West Bengal, and recently I visited. I had gone to my one marriage, no, last to previous week, an engagement I had gone. So there, I saw one small robot was there. Okay. one small robot was there. Maybe it is like very small, like a 6 inch, 12 inch, something like 1 to 1.5 feet. Okay. And what it does is like it is programmed every day 7 to 7:30, right? Morning. It picks up a bucket. Okay. There is a tap. It goes open it, fill some water, take this water, okay, and start mopping the floor. I was surprised. And when so it will go and see when in which places objects are there, and under the table it will do, okay, more cleaning. It is only doing mopping. Very small robot, but it does very neatly. Then it goes to kitchen. Slowly it will go to kitchen and just clean it. Okay. And when work is done, it will go and keep the bucket uh, from where it has lifted it. Okay. So see, in a very remote area, also these robots have increased, have come. Right? So what must have happened is today also. Right? So this robot was created initially, and it was trained on whatever activity it is supposed to do. So it has, right. So when it was first developed, so I heard that people from China and Vietnam, okay, they were having online sessions and they were teaching this robot how to fill water. Okay? How to fill water in bucket. I'm just giving high level. Then second is like how to lift. So they were lifting the bucket, they were filling the bucket, and this robot was observing it. Okay? The, then they came out of kitchen, they went to a small place, right, underneath the table, and they cleaned. So here each step this robot was learning, right? And this way, like this training was done for 3 years, or maybe 4 years also. So continuously someone online were teaching all these activities to this model. Okay, this model is programmed inside, and now it is doing very good work. And prices are like 5K to 10K only, 5K to 7K. It is China model. So China has gone far ahead in AI/ML field. So can you just think that which model might be applied here? Not model name, from
Reinforcement learning.
yeah. So it was reinforcement learning. Okay. Clear, team?
Yeah, bro.
Yes.
Yeah. So I'm going for what is linear regression today. Okay. So far, if there is no doubt, since we have time, and tomorrow we will do the complete practical for this. Okay. Just now we learned what is linear regression. So far, no doubt, right? This is very basic model, which is called linear regression. So how will you define it? Just now we saw, based on label data, what is linear regression? So
The dependent variable will be calculated based on the
yeah,
independent value.
yeah. So maybe you can define like this. It is a supervised machine learning algorithm which is used to predict a the data was labeled, but it was continuous. Maybe 10 hours, 20 hours, 30 hours. So some continuous data I were giving. We did not give -10, -6, something like that. It will predict, but your data is continuous, means there are less number of variables. Only two variable was there. One was price, another was no, it was hours, and that was marks. So let's first define this regression. I'm not going on bookish definition and all. So whatever we are learning, we should keep in mind, okay, so that it will be staying in your brain. Okay. So linear regression, first one is it is a supervised. It is a supervised machine learning algorithm. So what is the meaning of supervised here? Can someone please guide me?
Labeled data.
Yeah, so all the data will be labeled here. Means data will have a name. Second thing is, right, it is used to predict a continuous numerical value. So all should be numerical. Okay, it should not be true, false, or something. It is used to predict a continuous and numerical value. Plus numerical value. It won't predict a string. It won't predict a true and false statements, 0 and 1. Okay. So these are very important things for linear regression. Right? And what it does is, it tries in this algorithm, you remember, right? We try to find a straight line like this. So this straight line is called as best fit line. Right? This algorithm tries to find the best fit line. If you understand these things, so half of your work is done for linear regression. Okay? Tries to find the best fit line. Okay? And best fit line from where? From label data. So examples, maybe you can calculate salary. If you want to calculate salary based on experience, you want to calculate percentage, you want to calculate marks, you want to calculate house price, you want to calculate that based on advertising, like how much sales has happened. So all these things can be done using linear regression. Okay? So linear regression is a supervised machine learning algorithm. Okay. It works only on label data. Now data should be continuous and numerical. String and all, it won't work. For that, we have different models. It tries to find a best fit line, and right, that best fit line is created based on your label data. Okay. And this model's formula is, for one variable, it is this. Y equal to mx plus c. But suppose there are more variables. So what will happen? Those things we'll learn in logistic regression. So this is the, using this only, it will do best fit line. It will draw best fit line using this. Okay. And can someone please tell me what is M and what is C here? Where M is slope,
Intercept.
C is intercept. Now let us see what is slope and what is intercept. So if suppose your line is like this, so every time the line will not pass from origin. So suppose you are finding slope at this point, and slope can be found only on 2 points. So slope will be like this. If you draw a triangle here, so this theta will be slope. So tan theta in this triangle, right? The triangle, suppose this is point A, B, and drawing ABC. This is theta.
സർ ചെടി സ്ട്രേറ്റ് ആയിട്ട് തന്നെ ഇരിക്കും. ചെടിക്ക് മീൻസ് ഉള്ളിൽ നിന്ന് പറഞ്ഞൊന്നും പോയിട്ടില്ല, പക്ഷെ ഇല കുറച്ച് തിന്നിട്ടുണ്ട്. മീൻസ് ഇല തിന്നിട്ട് അതിപ്പോഴാണ് ശ്രദ്ധിച്ചേ. ബാക്കി മീൻസ് അതിൽ നിന്ന് പറഞ്ഞൊന്നും അങ്ങനെ പോയിട്ടില്ല. വേരോടെ തന്നെ ഇതായിട്ട്
Can someone
സ്ട്രേറ്റ്
please
ആയിട്ട്
mute? Who is talking? So tan theta will be this is P perpendicular, this is base, and this is hypotenuse. So this will be perpendicular by base. So tan theta is how much? Let's assume this is your this point is x1, y1, and this point is x2, y2. Then this will be, this length will be, this is y2 minus y1, right? And this is horizontal, this will be x2 minus x1. It means y2 minus y1, x2 minus x1. So this is nothing but change in y. y2 y minus y1 is what? Change in y. This is called change in y, delta y, change in x, delta x. And this is known as, for a small value, this will be coming at dy by dx. Okay. So dy by dx is nothing but slope. If someone who doesn't understand this, then let me know. How did I find this? What about?
theta equal to P by V.
No, that is fine. I'm just explaining how to calculate. You should not forget.
Okay.
I don't want you guys to remember anything. Okay, fine. So it's not drawing like that. Okay. Now, I have a point. This is your straight line. Suppose one point is here and another point is here. Okay. So these are points. So in order to get this point, you have to travel until this, right? And you have to travel in y also. This is y axis, this is x axis. Suppose this point is, the coordinate is x1, y1, right? It means here to here distance is x1, here to here distance is y1. Right? Now this point is x2, y2. I'll tell with an example also. I'm just giving you the basic. In order to reach here, how will you do? From here to here, you have to come here. Now this is x2. Now from here to here, how are you reaching? This is y2. Right? Now I want to find, right, theta here. So draw a perpendicular. This is your theta. Now I just want to get the value of this, no? The length of this will be c. You can find here also. It is nothing but x2 minus x1. This line will be here to here is x2, here to here is x1. Then this will be x2 minus x1. So whatever is here, same thing will come here also, right? Because both are same. If you draw a rectangle here, suppose I'm drawing a rectangle here, just for your understanding. So this length is equal to this length. So this will become x2 minus x1. So now this is A, B, C. So my AC, this is A, B, C. This AC became x2 minus x1. In the similar way, what will be this length? This length will be this one. This is y2, this is y1. So this will be y2 minus y1. So this, if you draw a rectangle here, so this length and this length are equal. So this will become y2 minus y1. So this is also y2 minus y1. Now this is theta. And in order to find theta, I have to find tan theta. So now from this triangle, tan theta is equal to perpendicular by base. This is your perpendicular. This is your base. And this is your hypotenuse from Pythagoras theorem. So this tan theta is BC by AC. BC is how much? Y2 minus Y1. And AC is x2 minus x1. Now we can also say, right, this is a change in y. Y2 minus Y1 is change in y. So you can write it as delta y. in maths, wherever there is change, we can say is delta y. And this x2 minus x1 is change in x. So this is delta x. When this change is very small, right now it is very big, but in machine learning, there will be points very nearby also. So this x2 minus x1 will not be this much. Suppose the points are very near. This is a point, right? So when you draw this triangle, right, very, very small. So this, now del y we are writing, it will be taken as dy. D means very small. Okay? This d means very small, means 2 points are quite near to each other. So you will not be able to draw triangle, but the same concept will apply. Okay? So this is tan theta. Right? And when tan theta is very small, right, this will become theta. Theta equal to dy by dx. And this tan theta was nothing but slope. Right? So what is happening now? Right? We were in this straight line, right? I was able to tell you what is m, what is mx plus c. Now this m is nothing but tan theta. Not write, do not write this. It will confuse you. This tan theta is slope, and slope is denoted by m. So this m is nothing but tan theta. So you can write it like this. 1 minute, guys. This m equal to dy by dx. Right? And what is c here? Intercept. So c is this distance. Right? C is this distance. Intercept means how far this point is from origin. C is intercept. Intercept means this will be y-axis value, right? Means how far is the line, right, from origin. Okay. Let us try with a couple of examples. Okay. Suppose I have this line. One is this, another is this. Okay. Another line is this. So these are lines. This equation is y equal to mx plus c. This is also like that. Now this is origin, okay? 0, 0. So here this intercept, see this line is directly coming to origin. So the distance of this line from origin is 0. Right? So in this case, intercept is 0. In this case, origin is here. So this distance will be c. And here also 0, 0 is there. Now this distance is intercept. Getting right? When the line meets with y-axis, then how far it is from origin? This is known as intercept. Okay. Now tell me in which case intercept is more and which case intercept is 0. I mean, this is first case, second case, this is third case. So minimum intercept is
S1.
1 and maximum is
S3.
yeah. So this is how we should think when we learn something from basic. Hope it is clear with everyone. Is there someone who has not understood?
No, bro, can you just go back to the notes, bro? Copy
1
the
minute.
formulas, please.
Yeah, Lina.
Yeah, it's just a bit of
Here.
oh. A bit of no, not that. To the tan theta. Yeah, that's one. Yeah, I'm clear, bro. I'm just taking the notes.
All right. So this concept tomorrow we will apply and we will predict on couple of data sets, okay? And see how the best fit line can be drawn. What are the assumptions we make in machine learning during linear regression? Okay, all these things will come tomorrow.
Oh, a little above.
Huh?
Let's
Above.
listening. Above. Above.
You want me to minimize?
Above. Yeah, I can minimize it just a bit above.
Yeah, I don't do.
That's above.
Which one you don't understand? I'll explain. No
No,
problem.
I understood, bro. I was just listening. I couldn't take the notes. If I could
Okay.
write, I would just miss your point. So I was just listening. So I
Yeah,
just
yeah.
want to draw all these.
Please draw. Okay. So guys, you guys are taking notes because
Yes.
Yes.
Yes,
Yes,
Kedar, we
Kedar.
will.
Oh.
sorry, ma, I just
Yes.
okay. Let us discuss what is linear regression. Who will tell me?
Linear regression is y equal to mx plus c.
Yeah, that is the math inside it.
Okay.
So
Little bit below. Bro. Scroll
linear
below.
regression is a machine learning algorithm, right, which is based on label data. In order to create linear regression or in order to apply linear regression, our data should have name, right? Like cat and dog image I gave, then housing price, right, was having like price and area, right? So linear regression is such algorithm, machine learning algorithm, which works only on label data. Second condition was the data should be numeric and continuous. And
No,
third thing was
scroll
and
little below. Thanks.
and third condition was how it predicts. It draws a best fit line from your test data. These three things please keep in mind, guys. No need to remember. If you're taking notes, done.
Okay. Linear regression is machine learning, works on labeled data. Data should be numeric and continuous.
Yeah, so it is a machine learning algorithm, or you can say it is a machine learning model. Okay? It's not machine learning. It's a part of. It is a model machine.
Okay. And
Okay? So
it
linear
try to
regression is
find.
a machine learning algorithm which works on labeled data.
Okay. Data should be numeric and continuous.
Yes.
And it find the best fit line to predict the data.
Yeah. To predict the unseen values.
Unseen values. Okay.
Which means new values on it. You'll give new value, then only it will predict.
Okay.
Because for all the values, whatever values are there, already we have a price available for that.
Okay. Okay. Yeah. For prediction of the
New value. Prediction of
value.
unseen values is done using machine learning.
Okay. So say
And
algorithm, machine learning algorithm.
yeah,
Little up below the almost done. That's good. Yeah. Thank you.
Prashant, Maithili, are you guys understanding? Taking notes?
Yes, sir.
Okay, very important, guys. This is the foundation of machine learning. Okay, so far 4 months, whatever we did was like your building blocks. Those were pillars. Now we are creating the roof. Then only you will be able to live in that house. Our house is not complete. Are you done, Lima? Or should I go down?
Yeah, I'm done. I'm done. Thank you.
Yeah. So we'll meet tomorrow again.
Okay.
Thank you, team.
Thank you, bro. Thank you so much.
Thank you, sir.
Thank you, everyone.
Thank you, sir. Thank you.
Thanks,
Thank
Maithili.
you. Thank you, sir.
Bye, guys.